Thermogenesis, the process by which the body produces heat, is gaining significant attention for its potential role in promoting longevity and overall health. This concept involves exposing the body to extreme temperatures, such as those encountered in saunas and cryotherapy sessions, to activate beneficial gene pathways and physiological responses. This article delves into the science behind thermogenesis, how it influences health, and the evidence supporting its role in promoting longevity. The science of thermogenesis. Thermogenesis can be induced by both heat, like sauna use, and cold, such as cryotherapy. These extreme temperature exposures stimulate a variety of physiological responses aimed at maintaining homeostasis. 1. Heat-induced thermogenesis. Exposure to high temperatures, such as in a sauna, induces heat shock proteins, or HSPs. HSPs play a crucial role in protein folding and protection against cellular stress. They help in repairing damaged proteins and preventing protein aggregation, which is associated with age-related diseases. 2. Cold-induced thermogenesis. Cold exposure, as seen in cryotherapy or cold water immersion, activates brown adipose tissue, known as BAT, and increases the production of norepinephrine. BAT is a type of fat tissue that burns calories to generate heat, a process known as non-shivering thermogenesis. This can lead to improved metabolic health by increasing energy expenditure and insulin sensitivity. Activation of beneficial gene pathways. Thermogenesis influences several gene pathways that contribute to health and longevity. Heat shock response. The heat shock response is a defense mechanism that involves the increased expression of heat shock proteins. These proteins enhance cellular repair mechanisms and improve the ability of cells to cope with stress, which is critical in aging and longevity. Cold shock response. Cold activates genes related to mitogenesis and function. This includes the upregulation of peroxisome proliferator activated receptor gamma coactivator 1 alpha, a key regulator of energy metabolism and mitochondrial function. Enhanced mitochondria is associated with increased energy production and reduced oxidative stress, both of which are beneficial for longevity. Hormesis. Thermogenesis acts as a form of hormesis, a process where low levels of stress stimulate adaptive beneficial effects in cells and organisms. This mild stress induces protective mechanisms that enhance the resilience and survival of cells. For instance, the activation of antioxidant pathways and increased autophagy, which is the process by which cells remove damaged components, are common hormetic responses. Health benefits of thermogenesis. Improved cardiovascular health. Regular sauna use has been associated with a reduced risk of cardiovascular diseases. A study conducted in Finland found that frequent sauna users had a lower risk of sudden cardiac death, coronary heart disease, and all-cause mortality. The cardiovascular benefits are thought to arise from improved vascular function and reduced blood pressure. Enhanced metabolic health. Cold-induced thermogenesis can improve metabolic health by increasing insulin sensitivity and promoting weight loss. Activation of BAT and subsequent calorie burning can help mitigate obesity and related metabolic disorders. Studies have shown that regular cold exposure can enhance glucose metabolism and reduce fat mass. Neuroprotection. Both heat and cold exposure have been shown to have neuroprotective effects. Heat exposure increases the expression of brain-derived neurotrophic factor, or BDNF, which supports the survival and growth of neurons. Cold exposure, on the other hand, reduces inflammation and oxidative stress, both of which are implicated in neurodegenerative diseases. Evidence from scientific research. The benefits of thermogenesis are supported by a growing body of scientific research. Heat therapy. A review published in Experimental Gerontology highlighted the potential of heat therapy to improve longevity and health span through the induction of heat shock proteins and hormetic effects. Cold therapy research published in Cell Metabolism demonstrated that cold exposure activates BAT and increases energy expenditure, suggesting a role in managing obesity and metabolic health. Sauna use. A longitudinal study in JAMA Internal Medicine reported that frequent sauna bathing was associated with a significant reduction in the risk of cardiovascular and all-cause mortality among middle-aged men. Thermogenesis, through exposure to extreme temperatures, presents a promising avenue for enhancing longevity and overall health. The activation of beneficial gene pathways, improvement in cardiovascular and metabolic health, and neuroprotective effects underscore its potential. While more research is needed to fully understand the mechanisms and long-term benefits, existing evidence supports the role of thermogenesis as a valuable health intervention.